Electronegativity has to do with the attraction an atom has for electrons it's sharing with another atom. So that's what makes electronegativity different from electron affinity. Electronegativity is an attraction for shared electrons. Electron affinity is an attraction for a free electron. It's the same factors that affect both of those properties, but they're not the exact same properties. So this is for shared electrons specifically. So if we're looking at an atom, we're talking about electrons it might be sharing with another atom in a bond, a covalent bond. It could be a single bond, double bond, or triple bond. The factors that affect this, so it will attract electrons more with less shielding and more protons. So it's the same factors that affect the size and in the same order. So if you have less shielding, if you have two atoms, we could compare like fluorine versus nitrogen. Maybe they're both bonded to hydrogen. Right? Fluorine's electronegativity is 4.0, nitrogen's 3.0. Well, why? Well, it's because fluorine has more protons. So they both have their valence electrons, so their core electrons are in n equals 1, their valence electrons are in n equals 2, and they have similar numbers of electrons. So they have similar amounts of shielding. So then we would look to see that fluorine has 9 protons, nitrogen has 7. So that's why fluorine attracts the shared electrons more. So that's going to mean that this bond is a more polar bond than the nitrogen-hydrogen bond. If you were to look at, say, fluorine versus chlorine, fluorine is 4.0, chlorine is 3.0. Here the difference, though, is the difference in shielding. So because chlorine has a whole other layer of electrons, if we were to look at what chlorine looks like, even with 17 protons in its nucleus, it has the 1s real close to the nucleus. It has the 2s and the 2p. Those are full. And then the electrons that are shared are in the third energy level for chlorine, because that's where its valence electrons are. So there's electrons. It probably has a couple lone pairs out here. But the ones that are going to be shared here between this atom and the neighboring atom, those are in the third energy level. And if I compare that with fluorine, which has only 9 protons, but fluorine only has the 1s really effectively shielding it from any electrons, because the second energy level is where all its valence electrons are. So the valence electrons here are n equals 3. Here the valence electrons are in n equals 2. So you could make an argument that chlorine could be more electronegative because it has a lot more positive charge in its nucleus. But we know generally shielding is a bigger factor than the quantity of positive charge. And that's evidenced experimentally because fluorine attracts electrons better from a bond than chlorine does. And so if we did have fluorine and chlorine bonded together, the electrons that are shared, these electrons here, that are shared in between, they would be shifting more toward the fluorine because its nucleus is much more exposed with significantly less shielding.